All right, lesson 4.1, reverse chain rule, anti-chain rule, U-substitution. If you take the derivative of this, you would multiply the front by 4. You would then subtract 1 to the exponent. And then there's a hook. And the derivative of 1 plus 5x is 5. If I took the derivative of sine, that's cosine, 1 plus 5x, and then the hook, the derivative of 1 plus 5x, the hook is 5. That's taking the derivative. What happens if we work backwards? So I want you to notice the hook comes from the base. The derivative of this is 5. To work backwards, we unhook this and then add 1 to the exponent and divide. And don't forget the constant. Same thing here. The derivative gives me the hook. There's the hook. We unhook it, and then the antiderivative of cosine is sine, 1 plus 5x, and then don't forget the candy. That's the work we're going to do. You hooked on the derivative, so you had to unhook when you go in the other way in examples 3 and 4. Each of the integration rules from the last lesson now can be generalized as the reverse chain rule. And so here we had the power rule. Here's the general one with the hook. The same idea is where you add 1 to the exponent and then divide, and then don't forget the constant. Trig rules are all here. And then these are the ones with the hooks. Same idea for us for reference. So let's start with number 5. Step number 1 is to recognize where the hook comes from. So the derivative of 3x subtract 1 is 3. That's the hook that I need. So write down the hook you need. Sometimes the hook's already there, but in this case it wasn't. The number that was there before was 1, and it became a 3. So we need a fraction so they stay the same question. And the easiest way to find that fraction that needs to go in front, so when you multiply, they're the same question, it's the top, subtract the bottom, what it was before over what it became. It's 1 over 3 right there. Now circle the hook and unhook it. Our question's going to start, our answer's going to start with that fraction. And then we do the integration. We add 1, divide, and then don't forget the constant. If I look at number 6, look at the one with the bigger exponent. So right here, what's the derivative of that? That's 3t squared plus 2t. That's exactly what's there. That hook is perfect. So I unhook it. The exponent you don't see there is 1. So then I add 1 to the exponent, divide, and then the constant. Number 7, I need to first write calculus friendly. So we're going to write this as 4x cubed subtract 5 to the exponent negative a half. So there's step number 1. The next step, I'm going to do it right underneath. What's the hook that comes from the base? So take the derivative of the base. That's 12x squared. For the anti-chain rule to work, when you find the hook you need, these have to be like terms. What's there before and what it becomes. I can change a constant, but I can't change a variable. So they must be like terms for this to work. They are. And then what's the fraction? We're going to go top, subtract bottom. What was it over what it became? So 6 over 12. I'm going to write that answer as 1/2, and then I add 1 to the exponent. So negative a half plus 1 is positive a half. Instead of dividing by a half, I multiply times the reciprocal and then the constant. 1/2 times 2 does cross out, so this would be the answer here. I want you to notice in number 8 that if I take the derivative, it's 3y squared in the base. It doesn't match what's in front. They're not like terms. So I have to go in a different direction. So what I'm going to do for number 8 is I'm going to FOIL it to be able to integrate it. So when you FOIL, it's going to be y to the 3. You can do that right here if you need to. So y to the 3 times, so that's y to the 6th. That's y and cubed and y cubed. So that's 2y cubed. And then 1 times 1. And now there's another strategy to use At this step, you just add 1 and divide, add 1 and divide. I don't worry about simplifying it at this step, and then you have your answer. The hook comes from inside the parentheses. So the derivative of 4x is 4. What was it before? What did it become? We need a fraction of 1/4. Then I circle the hook and unhook it. The answer is going to start with 1/4. And then I do the antiderivative rule for sine, which is negative cosine. And it's done. Number 10. In number 10, cosine theta squared. Think of that like this. So, inside the parentheses, the hook, the derivative of theta squared is 2 theta. Think of it like x. What was it before over what it became? Got blurry. Circle the hook, unhook it. We start with 3/2. The antiderivative of cosine is sine, and that's it. And then don't forget the hook. Oh, got one down here, almost snuck down here. Number 11. So for this one, I think it's better to write it like this. It's sine x squared. The hook comes from inside the parentheses, which is sine x. The derivative of sine x is cosine x. So the hook is there. And then I add 1 to the exponent, divide by that exponent, and then the constant. Turn the page. All right, sometimes you can't do the anti-chain rule, so sometimes it takes a much longer process to figure out. It's called U-Substitution, to be able to make it simpler, to do some algebra so that I can do the integration. And so usually there's a complicated part, and we let u equal what's underneath. Like usually it's a square root sign, but it can be other things. And I'm going to go through the steps. The steps are here. I'm going to go through the steps here in number 12. So the first thing I look at here is I want to make it calculus friendly. The hook comes from inside the parentheses. The derivative of x subtract 1 is 1. What's in front are not like terms. So the hook should be 1. I have an x. Unlike terms, I can't do the anti-chain rule. So U-substitution, what's inside the parentheses, which is x minus 1. Then we're going to solve for x. So we're going to add 1 to both sides. So x is equal to u plus 1. And then I take the derivative. So the derivative of x is 1 with a dx. The derivative of u is 1, but it needs a du. And the derivative of 1 is 0. So this is what I'm going to substitute in. So I come back to the question. Where there's an x, I'm going to put in u plus 1. X minus 1 is u. And then dx is du. That's called U-substitution. Now some algebra. I'm going to distribute. So u to the half times u. Remember there's an exponent of 1. We add the exponents. That's 3/2. U to the half times 1 is just u to the half. And now we're ready to do the basics of integration, which is to add 1 and then divide. So the easy trick to add 1, 3 plus 2 is 5/2. Instead of dividing, do the reciprocal. Again, 1 plus 2, that's 3/2. Instead of dividing, do the reciprocal. And then the constant. Now at the very last step, we need to take u back and put x back in. So u is x minus 1, so the very last step is to put in x minus 1. And you have the answer. Not bad, but it's just a lot longer to do a U-substitution. It's your last resort. Number 13. I'm going to write it calculus friendly. After I write it calculus friendly, the derivative of 2x plus 3 is 2. That's unlike. That's why it's a U substitution. So we're going to let u equal what's inside the parentheses, which is 2x plus 3. We're then going to solve for x. So I'm going to subtract 3, and then I'm going to divide everything by 2. After I do that, I'm going to take the derivative. This is 1/2, so the derivative of 1/2 u is 1/2, but it needs a du. The derivative of a constant is 0, and the derivative of x is 1, but it needs a dx. So this is what I'm going to use for the substitution. So now I go back to the question. Where there's an x, I'm going to put in 1/2 u subtract 3 over 2. And then subtract 1, close it. 2x plus 3 is u, that's to the negative 1/2. And then dx is 1/2 du. And I'm going to put the 1/2 in front. That's a property of integration I can do. So if I'm multiplying by a constant, I can factor it out in front, and then I don't have to worry about it. I could also do this, that 1, and why don't I do? Like 1/2 times 2, that's now taken care of. But then I got to deal with fractions. Doesn't matter. Here, just leave the, I can go 1/2 times 2. Let me do it this way. And then inside here, I have 1/2 u. And then to subtract, see, I have commented, it would have been easier if I didn't. So why don't I just leave the 1/2 here? Because what happens is that 2, I can multiply. So like 2 times 1/2 is 1u. 2 times 3 over 2, the 2's cross out, that's negative 3. That just makes it way easier, right? Why not make it easier? So I'm going to leave the 1/2 in front because it didn't make it easier, so I backed up. Negative 3 subtract 1 is u minus 4. And then I'm going to distribute. So u to the negative 1/2 times u, add the exponents, that's u to the positive 1/2. Negative 4 times u to the negative 1/2 is just that. They go beside each other. And then at this step, you can actually do the integration. So 1/2's in front, parentheses. I'm going to add 1. That's 3 over 2. Instead of dividing, I'm going to do the reciprocal. Again, I'm going to add 1. That's positive 1/2. And instead of dividing, I'm going to do the reciprocal. And then the constant. The last step, I can leave 1/2 in front. Unless, if you need to multiply it through, you could. U is equal to 2x plus 3. So you put that back in at the end. Oops. U is 2x plus 3. And there you go. And if you multiply the half at the end, the 2's cross out, and you get 1/3, 2x plus 3 to the 3 halves. 1/2 times 8 is 4. And you are now an integration wizard. All right, Mr. G Math, over and out. And now we'll do our assignment together. Till next time.